So hi everyone. I hope you guys are enjoying your first day and a half of the San Francisco Summit 2022. I'm honored for you to join me today on the winding down of the summit to talk about how to reuse patterns when developing infrastructure as code. Specifically, we're going to talk a little bit about the capabilities and features of CloudFormation and CDK. So I'm actually going to start today's talk with a quote I really like. And hopefully this quote gets you in the mood or inspires you to leave today's session, go back to your organization, and start deleting a bunch of code. And I joke about that, but I've hopped around quite a bit in my career. And mostly that was a product of being involved in startups. And I would get bored, after I automated all the things. So I moved around quite a bit. And one of the things I found myself doing was, as I joined a new organization, I would join an organization that wasn't as mature in their infrastructure as code strategy. They were likely just starting out on their DevOps journey. So I was the one that would come into that organization and write a bunch of CloudFormation, or other infrastructure as code. And I did that so many times, and I wrote the same lines of code over and over again, whether that was from org to org, or that was, from service to service within an org. And I just grew to hate infrastructure as code. I hated CloudFormation. So my point being here is, right, we have tools and patterns that AWS offers that I think alleviates a lot of those pain points that I felt in the past, and that's what we're going to be talking about today. So quick agenda slide. We're going to start off. I'll introduce myself, tell you a little bit about who I am, what makes me me. We'll review some of the challenge statements that we're looking to solve as an output of this session. I'll introduce some options for you, let you know the differences of those options. And then throughout this presentation, we'll talk about leveling up and reusing this code patterns. That's a big face. And I'm new to these silent sessions, so I wanted to give you, if you see this face and this is a slide deck, you can match it to this stage. But a little bit about me. So my name is Ryan Bachman. I am a Senior Specialist Solutions Architect here at AWS. One of my roles as a Specialist Solutions Architect is to work with our customers to adopt what we call our Builder's Experience tools. So those are going to be your code suite services, code build, code pipeline, code deploy. I also have conversations around our SDKs, our IDE toolkits, and our IDE in Cloud9. But I also talk a lot about our infrastructure as code services, being CDK and CloudFormation, and that's what we're here to talk about today. I come from Raleigh, North Carolina. Like I said, I've jumped around quite a bit in my career. I do like to share a little bit of fun facts when I do these things. It kind of helps me feel a little bit more human. So I am an avid traveler. I think my count is at 74 countries. Across 6 continents. I try to do 2 new countries a year. I have some makeup work this year, so I think I'm doing 5 this year to make up lost time from COVID. And then I'm also a youth football coach. I put this out because it's interesting. I have no idea what I'm doing as a football coach. Absolutely no idea. I'm just a cheerleader. I think I sit on the sidelines and high five the kids. And then the assistant coach does all the coaching. But yeah, it helps me connect to my 8-year-old son. And so I coach his team. And then finally, I have 9 AWS certifications, though I think some of those are expired. Don't tell anyone. Okay, so the challenges that we're trying to solve as an output of this session. So one of the things that we get asked at AWS is a lot of times best practices, right? I'll get asked, what's the best practice around this? What's the best way to do X? In addition to that, customers want to know best patterns around architecture. What's the best way to connect A to B, or B to C, or A to B to C? And so a lot of times organizations will wait for AWS to kind of validate their patterns or provide those recommendations. Or you may go read a blog that has sample code, and you'll go copy and paste that sample code into your project and then reuse that. And then you might have other service teams within your organizations trying to figure out the same thing, right? So there's a lot of wasted effort there, just trying to find out what's the best way to do things. Another question that we'll also get asked is, especially for infrastructure as code, let's say you have a shared services kind of layer within your platform, whether that's a shared database or it could be a shared event bus in like Kinesis or EventBridge. What's the best way to structure infrastructure as code? So things can be modular, and you could have a Lambda function, for instance, talk to a shared service. This modeling infrastructure, this is kind of what I alluded to earlier when I said I started hating CloudFormation. It is a repetitive slog a lot of times. I don't know how many times I created the same template that had a load balancer in it, to a launch config, to an auto scaling group, to the alarms. And I would do that, and I would spend maybe a few days putting tweaks, and then I would go to the next service and do that all over. It's a very repetitive task. It's almost like reinventing the wheel. So what kind of options do we have available to us to get out of that? And then if you look at all three of these things in aggregate, that's taking time away from your organization, from you, to actually do challenging stuff and stuff that's going to make a difference from your organization, right? So rather than spending time in the weeds of writing infrastructure as code that's been written before, how do we get out of that? How do we elevate and just focus on the things that really matter? So yeah, AWS to the rescue here. I feel like, I don't know, the silent session is kind of weird. I feel like we need to create like a FOMO, fear of missing out moment with everybody else. And we don't got too many neighbors, but maybe start a wave or something like that. All right, so AWS to the rescue. So what do we have to offer in here? So on the left-hand side, you're gonna see CloudFormation modules. CloudFormation modules are just encapsulated CloudFormation templates that you can embed and reuse in other CloudFormation templates. Across many stacks, right? So one module, you can put it into different stacks and reuse that code. And on the right-hand side, we have a object-oriented framework, a higher level framework of abstraction on CloudFormation that can be used to pattern and compose your infrastructure as code in a higher level language. And we'll talk a little bit more about these in detail. So what are modules and why should you use them? Excellent question, audience. Excellent question. So I alluded to this before. So modules are encapsulated common solutions. So we go back to the challenges about being asked best practices. Well, modules provide a way to codify that in a CloudFormation template, wrap that around, and kind of encapsulate. So you hide the complexity of wiring different resources together, or enabling certain features with certain settings. Modules are a way to abstract all of that and then just provide a basic interface or a basic input for others to consume, and just adjust minor pieces of that module. I mentioned they are opinionated, or they're opinionated practices. So by this, and I don't know if anybody else have tried this. So writing CloudFormation templates, you want to make them flexible. So I know of customers, and I've done this myself, is you want to promote reuse. So what you end up doing is writing a template with like hundreds of parameters, right? And now people that are consuming that template, there's a bunch of toggles that they can change, right? Like 30, 40 parameters. Well, modules are really intended to be opinionated. And what I mean by that is you're only going to parameterize the things that are flexible enough to change. So I'll give you an example that we're going to demo. Let's say you're creating a module around an S3 bucket. A secure S3 bucket, I'm sorry. So secure S3 bucket, what are the things that you need to do to make those secure? You might want to enable versioning. Might want to set a retention policy. You might want to enforce encryption. So if you look at how you might have done this in the past, you would create this template and all those things would be parameterized. But with modules, you really got to think about these opinions being, this is the way we're going to do things. These are what we want to enforce. and then only parameters are what you can change. So in that scenario, right, the only parameter that you would have to that module is probably your bucket name, and everything else would be fixed. And then the other thing with modulars, they can be published and versioned like any other code artifact. So rather than having to reference an S3 that's stored, or a CloudFormation template that's stored in S3, you now can publish this to a registry and then version that, which allows you to test and incrementally roll out changes. So here's an example. I talked a little bit about this secure S3 bucket. So on the left-hand side here, or what you see on the screen, this is an example of a CloudFormation module. Now, this should look awfully like a regular CloudFormation template, and that is because it is. CloudFormation modulars are no more than just a CloudFormation template with some schema structure around it, and we'll show you what that looks like in a second. These, because they are CloudFormation templates, they can be written in JSON or YAML, just like you would any other CloudFormation template. And then on the consuming side, so we talk about these being reusable snippets of code, you will just reference the specific module as a resource. So these resources are resource types. They are resource types modules. And again, we talk about like this encapsulation that this provides. The service teams or the developer that are consuming these and writing these simpler templates, you can see on the right-hand side, they don't need to know about the internals of what's being set in the module. They just need to know, again, what are the inputs and how do I interact with it? And then going a little bit further on that, so when we're using a module, they are used within the resource section. So they are treated just like any other resource type that you would define in CloudFormation. The differentiator is within the naming convention, there is a fourth element, which ends in module, that helps you distinctly see which one of your resources are associated with modules and which ones are not. And then I've also mentioned that these can be, on the consuming side, just like on the publishing side, they can be JSON or YAML as well. So this goes a little bit further in depth of what makes up a CloudFormation module. So on the left-hand side is the fragment, the template. This is used to generate the schema that is then used to publish to the registry. So you start with a CloudFormation template, which we consider a fragment, and then using the CloudFormation CLI tool that you can install using pip, you can use to automatically generate that schema file off that template. And the combination of those two are used to publish into the registry. Now let's look at like how modules, we see them being used, right? So on the left-hand side, we have a collection of publishers. Publishers are going to be AWS publishing modules. They might be your internal subject matter experts. So your architectures, your senior developers that are defining the patterns all within infrastructure as code. And then the community can also contribute to these modules. So, think of third-party providers or really anybody in the public that is authorized to publish to our public registries now can go ahead and write these opinionated patterns, publish these to the registry, and now you can browse a catalog of available modules for you to consume within your organization. And that becomes, on the public side, an opt-in model where you can browse the catalog, test out these registries, and then enable them for the rest of your organization. And so on the right-hand side is the consumer side, right? The developer, right? This is really intended to make it easier for the consumer, right? Through this abstraction encapsulation. So on the right-hand side, we're going to have developers, and then even your own template authors can digest these and iterate and improve them over time. And then what does this, or who does this model benefit? Hopefully everybody. And again, just to re-emphasize some of these points, we're using modules to encapsulate these best practices, right? So whether that be driven out of compliance, or maybe it is your tagging strategy that you want to enforce, what is best practice within your organization? What is best practice on AWS? When you consume a module, it's supposed to be a codified representation of that best practice. So rather than going to an AWS expert or an SME, if you consume one of these, there should be level of trust and confidence that you are getting best practices through code. And then the distribution of updates using a native version management that allows you to safely increment and iterate on these modules. And then on the consumer side, we talk about the adherence to best practices. So if I'm an organization and I have to, if there's certain expecting or certain things that I have to meet, this just makes it easier for me to go ahead and consume those best practices. We talked a lot about abstracting away the complexities. So that's what modules are really. One of the benefits of a module is as a user, I don't care what happens inside. I just know it's going to produce this thing that's going to work, and it's going to be modeled after best practices. And then the point of today's talk is all about code reuse. And so this is the big one, is we get away from recreating the same thing over and over again. We're going to recreate that template once and then consume that in our downstream projects. And then the other big one here is as you think about building these modules, think about these modules as composable patterns that now service teams can pull in and compose an application to what their requirements are, right? So modules aren't supposed to be necessarily full solutions, but rather these best practice building blocks that then organizations can use to build on top of. And then we talked a little bit about the registry. We have two registries here with CloudFormation. There's the private. The private allows you as an organization to publish to a private registry that you can consume, as long as you allow your accounts or other accounts within your organization to go ahead and pull from that registry. And then our public registry contains the modules provided from our third-party partners after a vetting process, as well as AWS published modules. And this is what the registry looks like in the console, and I'll actually, in the demo, pull this up. And within the console, and this is true with the API or CLI too, you'll be able to see the publisher name of that module, the version that's active as default, and any other metadata associated with that module. And then before I get into the demo, things to note as you're building modules. I mentioned this a little bit about like the opinionated encapsulation that a module should be. So you're going to modify the module's behavior as a consumer through parameter values, right? So you are still passing parameters into the module, and those parameters within the module, so inside the module, are set with a ref tag, just like you would with native CloudFormation. And then outside of the module, and I know it says inside, but if you need to get at attributes of the resources that are encapsulated within a module, you would just get the function get at, which would allow you to get the specific attributes of the resources that are encapsulated. And then finally, resources or properties that are not variable through references cannot be modified. So as you're about to see, we're going to do a demo, and we're going to create a module for a secure S3 bucket. Those settings that I set within the module cannot be overwritten by the consumer. Those are fixed. The only things that are adjustable are what is supplied through the parameters. And let me go ahead and demo this. Oop. Okay. So I'm going to start us off in our Cloud9 IDE. And the first thing I want to do when I create a module, I'm going to go to... so I mentioned, when I mentioned the schema generation, I kind of alluded to the CloudFormation CLI tool. That's already installed here in my Cloud9 environment. But to get started to create a module, I am going to go ahead and issue a CFN init command. And this is just going to lay down the scaffolding of the type of resource. So you can see here with CFN init, I can use to develop a new custom resource or a type hook. But for today's session, we're going to be talking about modules. So I'm going to go ahead and select that. And the first thing you want to do is go ahead and name your module. So I am going to, I don't know if we have any Seinfeld. Oh, cannot type. Oh, love these live S3. So now if we look at what CFN init created, you remember me mentioning the fragment file. So it's going to basically create a default or a hello world CloudFormation template for us to build off of. And then it also creates a log file that allows you to track the changes over time that you do in that directory. And hopefully over time, you would actually submit this into Git as well for future development. So let's go ahead and open up our sample file. I mentioned we're going to create this secure S3 bucket module, and that is what CFN init defaults to. So it's generated a template for me. You'll know here, or you can note, we have a deletion policy set for this, this S3 bucket. We're enforcing server-side encryption at AES 256. And we've also enabled version configuration. And this is where the opinion comes in, right? We're not allowing consumers of this module to interact with any of these settings through parameters. We're going to fix these within our module. And then the only thing we're going to allow to be passed in as an input is this parameter, which is the bucket name. So let's go ahead and publish this. So we didn't make any changes. So we just type in CFN submit. And what this is going to do, so CFN submit is going to generate that schema file for you. It's also going to lint that template file just to make sure that it is, number one, it's valid JSON, but it is also a valid CloudFormation template with the resources and the required attributes of the resources that you are declared. It's then going to publish into the registry and let you know that that particular module is registered in your private registry, which is this output here. And now if we go into our activated extensions and in our modules, you will see that the module that we just created is listed here. And I've been doing this a couple times today, so that's why we're at default version number 11. So now let's see what it looks like on the consuming side. So here, we just have a basic CloudFormation stack template. And you'll see in my resources section, I only have the type, and that's the modular that I just created and I published to the registry. And I'm passing in that property bucket name that the modular accepts. And remember here, as a consumer, as a developer, or even a service team that is creating this bucket, I don't need to know about what happens inside this module. You know, again, that's all abstracted and encapsulated away from me. So if I go back, and I just have some pre-baked commands to deploy it. So within command, I just issue a create stack with passing in the parameter of my bucket name, and it's going to go ahead and create the stack off that template based on the parameter that I put in. So if I go back to our CloudFormation, you will see that I now have an S3 bucket created. So now the question becomes, well, that's great. That's fantastic. I understand how to create modules and how to publish modules. But what do I do about maybe iterating over time? We talked a little bit about like iterate and improve. What if the policy changes for a secure bucket? What if we have to update the encryption type to a higher standard? Or what if we have to switch to a particular KMS key and not just the standard S3 server-side encryption setting? We can go ahead and republish some of those back into our modules. One of the things that I like to do with my modules, CFN. So go back in here. One of the things I actually like to do with my modules is actually set a particular tag within that module. What that allows me to do as an author of modules, I can now audit my various environments to understand what modules are being used throughout my organization, maybe what level of module or what version of module they're on. So for this demo, I am just going to add a tag property to my module. So I would go into my properties, tags. I think that looks good. And then if I go back here, so we made some changes to my module template. If I go back here and I issue a CFN submit, it's going to recheck to make sure I have correct syntax for my CloudFormation template. And then it's going to submit that back to my registry. Should only take a minute. Let me go back here and go back to my modules. So you remember the first version that we published was version 11, and now we're publishing a new version that should be available here any second. So within this response code, you'll see here that there's an ARN that maps, and hopefully you can see this highlighted, that maps to a new version. If I go back one more time to see what's activated, I refresh this, you'll see that we're still at version 11. So even if you publish new versions of your modules, by default, it's not going to advance. So you have to be explicit on when you set the new default version after publishing. So we're going to go ahead and do that. And I'm just going to grab a command from my history. So let's go ahead and grab this guy. And we're going to set it to 12 because that's what we just published. And now if I go back here, now you see it's 12. So now that I published the new module as my default, now if a downstream consumer of this module, so somebody that's using this module in their template, they are going to pick up my change automatically. So I go back into my deploy. I am going to, and remember, I haven't touched the actual underlying stack. So this is what my stack looks like. I'm not going to modify my template at all. I'm just going to issue an update stack command to pick up the new version of my template. And now if I go back into my stacks, I should see that that is being updated. And if I go further into my S3 bucket, and go into properties, we should see, and there's some delay, but soon here we'll see hopefully this last tag. This is what we added to our module. So without having to change anything in my template as a downstream service, the publishers of these templates, you can make modifications there, and that is an easy way for you to implement change to the downstream consumers upon update of stacks. One more thing that I want to touch upon before we move on to CDK is we talked a lot about rewriting these templates, how difficult or how painful. Now, this was just a simple one. This was just an S3 bucket. Now, imagine that you were creating one for what your VPC architecture should look like, or you're building something a lot more complex that has a lot more services. You would still maybe have to have a starting point to do that. So I'm going to give you a little trick, and this probably kind of combines and provides a bridge to the next topic, which is going to be CDK. But one thing you can do is use CDK, and I'll go into CDK, and we'll talk a little bit about CDK in a second. But you can use the power of CDK and the abstractions that the CDK provides to generate that first pass template if you're going to use CloudFormation templates in your environment. So using CDK, CDK will synthesize into a CloudFormation template. And so I can go in here, CFN. So in CDK, I'm going to start with this very simple VPC construct that I'm going to use. But I want to get this into a CFN module because my organization is standardized on CloudFormation. So I'm going to use CDK and the power of its synthesis capabilities to go ahead and issue something like CDK synth. And we'll talk a little bit more about this when we switch to CDK. And what's all happening here. But this is going to synthesize a CloudFormation template. And now, if I look at this CloudFormation template, I'll pull it up here. One line of code, produced, I think this produces like 600, 700 lines of code. And this is standard CloudFormation. So I now can use this as a starting point for more complex scenarios, and then turn this into a template and build upon that. So that's just a little trick if people are interested in building these complex CloudFormation templates. Or you can start with whatever you have already available to you. Which is going to lead me into AWS CDK. So AWS CDK, it's going to be, it's a higher level multi-language software development framework that, much like CloudFormation or other infrastructure as code tools, is intended for you to model your infrastructure as code. And then the theme in reusable components. The reusable components of CDK are what we call constructs, and we'll be talking a little bit more about the patterns and the use of constructs. With AWS CDK, one of the questions we often get when we talk about CloudFormation and CDK kind of in the same talk or the same session is, when do I use CloudFormation? When do I use CDK? It's not so much a matter of when you use it, it's who is going to use it, right? You're free to choose whichever tool that you're most comfortable with, whatever makes the most sense for you. At the end of the day, CDK relies on CloudFormation to actually do the provisioning and orchestration of these resources. But what we see from the people that adopt one of these tools is this is really, a lot of times, is persona-based. And by that I mean, right, as there's this shift and movement to shift left, to get developers, traditional developers, code developers, closer to infrastructure as code, and being able to define the resources and the dependencies of cloud infrastructure, AWS CDK helps with this shift because it's in a language that the developers are already used to, right? So we have support for Python and JavaScript and TypeScript and Java and C# and Go is also supported. And then the other thing that why CDK is adopted by developers is, I mean, frankly, it's a lot easier to write, in my opinion, as a developer, CDK code because it's integrated tightly with your IDE or your development environment. So, features that you typically rely on for development, such as type hinting and auto completion, are all built into the tool. So you can be living in your IDE and have that, those nice features that help you develop faster. And CDK is also built on a library of abstractions, and those are going to be the constructs that we'll talk a little bit about shortly. There's also a paradigm shift on how you actually generate the underlying CloudFormation templates when you compare CloudFormation to CDK. So in CloudFormation, when we built our module in the last section, we still were dealing with parameters, right? Parameters were our inputs to our modules or our template, and parameters allow us to influence what happens after the fact. So with CloudFormation, you have the combination of your template and an input parameter that gets put together, and at the end, you can generate multiple stacks based on different combinations of parameters to template. With CloudFormation, you shift that logic a little bit further up, right? CDK is built on, because it is a higher level programming framework, instead of dealing with like lower level resources, you're dealing with objects, class objects within the programming language. And those objects have constructors, and those constructors accept properties. And so when you are using CDK as modules, your inputs are at the code level, so the objects and the resources that you find in CDK, and then CDK will take those inputs to those constructs and then synthesize a template for each variable, right? So if you have a CDK app that you pass in, a handful of different inputs as an array, and let's say that there's 5 different combinations, CDK is actually going to output 5 different stacks, and then each template is going to map to a specific stack in CloudFormation. And just to give you some ideas of our construct libraries, so we have construct libraries, and construct libraries again are just those encapsulated artifacts that you can consume just to make your life easier as you're defining infrastructure as code. So we have, this is just a sample size of the different constructs that we offer through our construct library. So whether you're developing serverless type applications or application integration type resources that you need to define, to container-based applications, we have constructs and opinionated libraries around a lot of these kind of workload architecture types. So with constructs, there's going to be 3 different construct levels. At the very bottom is a L1 construct, and those are one-to-one mapping of the CloudFormation resources. So they're not really abstractions in a sense. They map directly to their likeness in CloudFormation. The reason why we need to have them is these L1 constructs are automatically generated anytime we add a new feature or capability to CloudFormation. We generate that in CDK off the spec file of CloudFormation. And so with these L1 constructs, CDK will not be behind CloudFormation, because anytime we add something to CloudFormation, these L1 constructs are auto-generated and free for you to use. L2 is where you start getting the opinions and some of the abstractions. So L2 constructs encapsulate a single service. So the one I like to talk about is the VPC, construct. So the L2 constructs are just, again, encapsulation around that single service, that single use case. They may have opinions, they may have helper functions built into them to make modifying or changing or defining those particular services a little easier in infrastructure as code. And then finally, at our top level is our L3 constructs. Now, these are going to be your purpose-built architectural patterns based on best practices to help you define more complex workflows with a single construct definition. So one example I like to give here is there's a library around ECS pattern constructs, and defining and instantiating one of those ECS pattern constructs might provide you a new VPC. It might provide you an ECS cluster. It's going to set up all the IAM permissions, all with one line of code. And then let's look at specific examples of each one of these. So these L1 construct, any construct that you see that starts with CFN within CDK is automatically an L1 construct. And you can see this one synthesizes down to the native CloudFormation resource. So I mentioned this VPC one, right? So this is an L2 construct. This L2 construct will, right? It has the intelligence within the construct based on your region. It may give you 2 availability zones, or if you're in a region that supports 3, it will give you 3 availability zones. It will synthesize, public subnets and private subnets. It's going to wire all the route tables for you. It's going to give you an internet gateway. And so when I talk about code reuse or best patterns or best architectures, this VPC diagram should hopefully represent to you what a best practice VPC should look like on AWS, right? So as I talk about, right, like how do you implement best practices with code? It's through these opinionated constructs or those CloudFormation modules that are just codification of those best practices. The other thing I'd like to call out here is with CDK, there are sane defaults. Just because you call this like this, you're accepting all those defaults and it will work. But CDK also allows you the ability to override or set any parameter inside that construct as well. And then finally, we have L3 constructs. So L3 constructs, like I said, span across multiple services. So I mentioned this ECS pattern one, this application load balance Fargate service pattern. A service team can just use these 6 lines of code, and that's going to generate a complex architecture across 829 lines of CloudFormation templates. The other thing I want to call out here too about best practices is when you think about least privileges, you'll notice some of the resources that this creates is IAM and IAM roles and permissions. Well, when you instantiate a construct and allow that construct to create these IAM resources, which are going to allow services to communicate back and forth, allow services to maybe execute a Lambda, those IAM roles that are created with least privilege concepts in mind. And so it's only the 2 resources that are allowed to talk to each other, right? Like the policies that are in place using these constructs are only scoped to the particular resources that are within context to these constructs. And much like we have a registry with CloudFormation, we also have a constructs library with our CDK constructs. AWS will publish solutions. These are, and this is where it gets into the best practice, right? So our L3 constructs that we publish on our constructs hub, you can navigate, search for common patterns or certain architectures that you may want to replicate. And what we publish here are based on best practices, right? So these are reviewed by AWS engineers and experts. They have to get vetted, make sure that they adhere to our best practices, and only then will they get published to this construct, this solutions constructs. Similarly, like we had with CloudFormation modules, we also have a community place to publish your own constructs, which is constructs.dev. in here, and I think last time I checked, I mean, there's thousands of constructs. So whether it be a third-party provider or a third-party partner that wants to make it easier for AWS consumers or AWS customers to implement their solutions, you can find some of those solutions through CDK on our constructs.dev. You are also free to publish to construct.dev as well. So let's do a quick demo with CDK. Oh, yeah, so we're back here. So during the first demo, we really looked at how we were going to produce a module with CDK, and I'll show you that here in a second. Let me clear my screen. Oh. So when we created that module, we were creating a snippet of code for the rest of our organization to be able to use. You can do the same with CDK. So CDK provides you the ability to create your own constructs. Those constructs can be completely new, written by you. They can be extended from our existing constructs that are available to you through the library, and then you put your own layer of sauce on top of it. So there is the ability to create CDK constructs. And so if I do a CDK init here, much like CFN init provided me, like, what am I creating today? You'll see here that I am provided the option of, am I creating an app, a CDK app, a CDK lib? No, a CDK lib is going to be that construct that we want to create and publish back to our organization. And then there's a hello world sample app. So rather than go through that module creation, and CDK does support that, what I want to do here is consume an already published construct in spirit of reusing code, right? So the CDK library comes with these constructs that are authored by AWS that's supposed to make it easier on you and your organization to consume these best patterns. So that's what we're going to do today. We're going to create an app using the CDK constructs. So let me go ahead and clear this. So I'm going to do CDK init, an app. And then if you saw before, I can pick what language I want to do this in. So I am going to, for the purpose of this one, use Python. And much like CFN init created all the scaffolding and the required files, CDK init is going to do the same for me here. I need to install my dependencies. Already done that. And then I am going to just have some code set up so you didn't have to watch me type code. Oop. So now if we go look at what we're gonna do here. Sorry, this bright light, I can't see my screen all that well. So let's go here. So let's look at what we're going to create here. So with this CDK app, we're going to use two constructs provided by AWS. The first function or the first construct we're going to use is a Lambda function. Again, this Lambda function is going to provide easy ways to create the Lambda function with same defaults and set up permissions for us, all without us having to worry about any of that. And then the next thing we're going to do is create a Lambda REST API. So imagine we're building a application, a REST API application, an API gateway with a Lambda function behind it. That's what we're trying to build today. So you'll notice I just have a simple backend define with some really basic parameters defined, as well as the API, and I'm just passing in my backend as the handler And really that's about it, that all I'm doing here. So I think I have to do one more thing. And so now if I do a CDK synth, and what CDK synth is going to do is it's going to take the code that I wrote in Python. It's going to compile that down or not really compile. It's going to use that to transform or synthesize that CloudFormation template, much like the example with EC2 VPC that we did before. And now I can do a CDK deploy. And CDK deploy is going to use that CloudFormation template that was synthesized, and then push that to CloudFormation as a change set. One of the great things about CDK is CDK, because it's supplied as a change set, before you actually deploy any changes, you have the opportunity to review. And I know I've got a large font here, but this is what it's telling me. It's like, hey, we're going to create some IAM roles. We're going to create these resources. Do you want to proceed? So let's go ahead and proceed. The other thing CDK deploy here is doing under the cover is one thing I did not show as part of my demo is because we have a Lambda function, I need some code to run in my Lambda. That code is represented in the Lambda folder up there. And so CDK deploy is going to be responsible for bundling that code. And that's referred to in my CDK app code. It's going to bundle that code. It's going to zip that up, and then it's going to send that to S3. And then it's going to basically wire that reference within the CloudFormation template to let Lambda know where to what S3 bucket to get that Lambda function from. And CDK deploy handles all of that for you automatically. And so now if I go back to my CloudFormation, you'll see I have this CDK app stack. And just to show you like the value and the highlight of some of these opinions that are built into these constructs. So if we go back for a second and look at the actual Python code that I used to deploy and generate this architecture, again, I just defined this function and I defined this Lambda REST API. But if we go back here, and you're familiar with CloudFormation already, I have an output, right? I automatically have this output that gives me the URL of the API gateway that was created for me automatically. And that's some of the opinions that you can build into these constructs, right? Nowhere did I have an output defined like you would have to do in CloudFormation, where you have to be explicit about like what are you actually outputting. All that can be opinionated and wrapped within these modules. And just to show you, right, that this actually works as a running application, I go ahead and curl that URL. And we get a welcome to SF Summit 2022. So I started you off today with a quote. I'm going to end you with a quote today. So good programmers know what to write. Great ones know what to rewrite and or reuse. So I hope today provides you some of the patterns or the tools available to you through CloudFormation, through CDK, to go back to your organization and start thinking about what, where can we refactor? Where are my code, where am I duplicating my efforts? How can I make the life and the work of my developers easier by building these patterns, building these constructs, publishing these CloudFormation modules to your standard, to your organization policy, and we all become better programmers. So thank you. Oh. Sorry. Yeah, if you want to grab this obligatory, so we have our skill builder for free trials and then AWS certifications. But thank you. And my contacts up here.